Once again we are in the same topics, the electrophilic substitution reactions at the isoquinolines. So delocalization of positive charge over the complete structures, and finally it comes to its original point. So at the same points where substitution takes place, that is final state, we are going to study. I will draw how the final state and how removal of H plus ion takes place. This bond break and here plus charge with the addition of electrophile in the H plus ion. This H plus ion removed from here, and here is the formation of show you how the formation of double bonds. Hydrogen, electrophile, H plus, with the hydrogen. This hydrogen shift here, and here is formation of bond. This is a new binary structures, and this is a isoquinolines formations along with this electrophile. There is no change in the structures, only shifting of the bonds takes place in the original structure and the final structures. Electrophile take the position of hydrogens by substituting it, hence it is called as the electrophilic substitutions of the isoquinolines. Structure, if the numbers, then it is similar with the quinolines, that is the first, second, sixth and the seventh are the more stable structures. Electrophilic substitution at the position 5 and 8 give the localization without disturbing the pyridine ring aromatic natures, while that at the 6 and 7 position it would cause the disruptions of the ring and aromaticity get disturbed. This is a while that 6 and 7 position it will change the, in this case change the disruption of ring and the aromaticity get disturbed. So purpose of this reaction is at last we will get the aromaticity as it loses the aromaticity, and finally we will get the final same structures. This is the explanatory comparing the relative stability of the intermediates carbocation formed by the electrophile and the attack at different positions. So at the finals, most important is the aromaticity, because whenever if the compound is aromatic and if we are doing the reactions at that compounds, electrophilic substitution or nucleophilic substitutions, either finally compounds forms and compounds loses aromaticity, means that this is not a feasible reaction, thermodynamically not stable, these reactions will not be occurs. So whenever the reactions whenever there is reactions should always carry from the non-aromatic to aromatics, never from aromatic to non-aromatic, because it is not stable. reactions always goes toward the stability. So in the case of the quinoline or isoquinoline, whenever there is a formation of the bond, whenever there is reactions of the quinoline and isoquinoline, reaction is only possible when the if it is retained its aromaticity. So in the last state of these reactions, compound retains its aromaticity and compound gets aromaticity again. This is a stable and more stable reactions. So this is the explainably comparing relative stability of the intermediates. Carbocations formed by the electrophile and attack different positions. Next is the reactions of the pyridine, preparations of the pyridine N oxides. So how we can prepare pyridine oxides? The pyridine N oxide can be prepared from the pyridines. If the oxidation reactions takes place at the pyridines, we will get the pyridine N oxides. So for the oxidation reactions, we have the oxidizing agent, that is the hydrogen peroxide S2O2 along with the acetic acid CS3COOH. So pyridine can be easily oxidized by the alkaline hydrogen peroxide or by the peracid and obtain pyridine N oxide. So this is the reactions. Preparation of the quinoline by Schirup synthesis. How we can prepare quinoline? This is the most important reactions. Many times questions asked on the preparation of quinoline by Schirup synthesis. This is the name by it is asked by the name reactions. So the glycerol is the preparation of the quinoline by the Schirup synthesis. Important reactions. So glycerol is the dehydrated by using the concentrated H2SO4 give the acroleins. This is the first step where glycerol is reacted with concentrated H2SO4 and this is converted into acroleins. There is the reactions where removal of the water molecules in these reactions and oxidation takes place. Step second, acrolein is react with the aniline by the Michael addition reactions and give the 3N-phenylamino propanols. So this is next step. In this step, the aniline react with the acrolein, which is formed in earlier state from the glycerols. This react with the aniline means we will get the nitrogen atom and already the benzene ring. The addition reactions takes place and we will get the 3N-phenylamino propanols. So in the next step, that is step 3, acid catalyzed cyclizations and dehydrogenation gives the dihydrogen quinolines, which is react to H plus ions and gives the cyclization of the formations. And the last step, there is the formation of the aromaticity. Nitrobenzene use the dehydrogenations of the hydrogen and gives the quinolines. So the quinoline form in these reactions, quinoline form and aromaticity gain by the compounds. This is the final steps and this is the final compound form. So this is the most important reactions of the formation of the quinoline by using the Schirup synthesis. Schirup synthesis is used, especially used and only used for the synthesis of the quinolines. So quinoline prepared. Last step is that is formation of the aromatic compounds. For the formation of aromatic compounds, cyclization and removal of the H plus ions takes place and compound finally get the aromatic structure. So aromatic, as the aromatic structure form, it is more stable and more conforming states. So the friends, this is all about the preparation of the quinolines. Next topic video we will learn the preparation of isoquinoline by Bissler-Leprasky synthesis. Okay friends, thank you very much.